Hi everyone. So in this video, I'm actually going to review all the problems that we have done in class because this is probably the first time for a lot of people to study geometry. I want to build a good foundation for you. Okay, I want to, because the ruler compass construction requires a lot of knowledge and details about congruence of triangles, right? And it requires a lot of proofs as well. I think this is a good chance for us to, to build a good foundation for all of you to study geometry, okay? So if you think you've already understood everything that we discussed in class, you can skip forward to the questions that we didn't talk about in class. Okay. So the first question, copy an angle. Okay. So remember, everything we're doing today, we're only allowed to use two tools. One is a ruler without any numbers, and the other one is a compass. Okay. So keep that in mind. We're only allowed to use these two tools. Okay. So let's see how we do this. Okay. So we're given an angle, any angle. Okay. The angle is random. Let's call this A, B, C. Okay. How do we copy this angle? So that means how do we create another angle that's identical to this one? First step, of course, we need to draw a line segment here. So this step, we use the ruler, right? And the line segment does not have to be, does not have to have the same length as the first one, right? Because it's just an angle. So let's just call this BC, EF. Okay. And how do we create an angle that's identical to the first one? Okay. Step one, with the center at B, draw an arc cutting AB at X and BC at Y. So now we need to use compass. Okay. With the center at B, so now the compass is center at B, right? And now we'll draw an arc cutting AB at X and BC at Y. So AB at X, BC at Y. Right, that's the first step. Step two, draw a line segment EF. We did that already, so let's just skip that. Step three, with the center at E and radius BY. With the center at E and radius BY, draw an arc to cut EF at S. So now we first need to measure BY. So this is BY, right? And we need to put the center of the compass at point E, and we draw an arc, and the arc will cut EF at S. So we draw an arc, and the arc cuts EF at S. Okay. So far, what have we done? We drew an arc with radius BY. What does that tell us? BX and BY are obviously equal because BX and BY are two radiuses of the same arc. And like I said, I think I said this multiple times in class, an arc is part of a circle, right? And we know that all the radiuses in a circle are equal. With the same logic, we know that BX is equal to BY. Let's just write down all the details here. BX is equal to BY, right? And then what did we do? We measured BY. We measured BY. And then we moved the compass to E, and then we drew an arc with the same radius as BY. That means SE is actually equal to BY as well, right? SE is equal to BY as well. Okay, now what do we do? Next step, with center at S and radius YX, draw an arc to cut the first arc at D. What's the first arc? First arc is this one, right? We call this arc 1, okay? With center at S and radius YX. So, okay, so let's measure YX. So this is YX, right? And then we put this at S, and then we draw an arc. So we know that this is D, right? Because the step says with the center at S, so this is S, and radius YX, draw an arc to cut the first arc at D. So this is D. And now what do we do? Step 5, join ED, then angle DEF is equal to ABC. So now we need to join ED. And it's claiming that angle DEF, this one, is equal to angle ABC, this one, right? Like I said multiple times in class, following the steps is not the hard part, right? The hard part is, okay, you're telling me that this is the right thing to do, but how do you prove it to me? Okay. The hard part is proof. How do we prove, how do we prove that angle B is equal to angle E? We need to use the knowledge of congruence of triangles. Okay, so let's join XY and DS. We've already noticed that BX is equal to BY is equal to SE. But did you notice that ED, this one, ED, is also it is also a radius of the arc 1, which means ED is also equal to SE. And since SE is equal to BX is equal to BY, DE is also equal to BX and BY. Right? Because we know BX and BY are equal because there are two radiuses of the same arc. And then we use the same radius, we use the radius of BY to draw the first arc in the second diagram, right? So we know that SE is equal to BX and BY. But if you really look at the diagram, the second one, you'll notice that ED is actually another radius of the first arc in the second diagram, which means ED is also equal to SE, which is also equal to BX and BY. Okay, so we know this. Okay, what about XY and DS? When we drew DS, what's the fourth or third step? It says with the center at S and radius XY, draw an arc to cut the first arc at D, which means DS is equal to XY because we use the radius of the length of XY to draw the second arc in the second diagram, right? So we know that XY is equal to DS. So now what do we have? If we organize the information a little bit, we will have BX is equal to DE, right? BY is equal to ES. XY is equal to DS. What does this mean to us? With these three pieces of information, we can conclude that the triangle BXY is congruent to the triangle EDS because of SSS. Okay. If two triangles, if the corresponding three sides of two triangles are equal, we can conclude that the two triangles are equal, right? That's one of the conditions that can prove the congruence of two triangles, right? So here we know that triangle BXY is congruent to triangle EDS. Because these two triangles are congruent, we can prove that angle B is equal to angle E. You can draw a little square there to show that my proof is done. Okay, so this is how we construct, this is how we copy a given angle and how we prove that the steps are correct. Okay, so this is the first question. Second step, as our second question, is how we bisect an angle. So let's see how we do that. Let's say we have an angle here. We have an angle here. Let's call it A, B, C. Okay. How do we bisect this angle? Which means I want you to draw a line here so that this angle and this angle are equal. Okay, but remember, you don't have any other tools. You only have a ruler and a compass, right? So how do we do that? Okay. First step, with B as a center and any suitable length as radius, draw an arc to cut BA at X and BC at Y. So this is the first step is very similar to what we did in the first problem, right? Any suitable radius. I think this is suitable. So let's draw an arc. And we call, so like the arc cuts AB at X and BC at Y. Okay, what's the next step? With X at center and any suitable radius, draw an arc. Then with the same radius and Y at center, draw another arc so that the two arcs cut at S. So we put the compass on the point X and we pick any suitable radius and we draw an arc. Okay. And then we put the compass on the point Y and we use the same radius to draw another arc. So the first arc and the second arc have an intersection. So the intersection is over here, right? And we call this intersection S. Now we connect B and S. And the method is claiming that if you follow all these steps, then BS will be the angle bisector, which means, so the claim is angle BA, sorry, let's just call it, let's call this 1 and call this 2. So angle 1 is equal to angle 2. How do we prove it? How do we prove it? So if we connect a X and S, and Y and S. Whenever we use a ruler and a compass to construct some kind of diagrams, whenever we need to prove stuff, the most common method or the most common tool is the congruence of triangles. Okay, it's the same here. We need to prove that two angles are the same, are equal. The easiest, the most simple way is to prove that the two triangles that contain these two angles are congruent, which means our goal is to prove that triangle BXS and triangle BYS are equal, sorry, are congruent. Can we prove that? It's actually pretty easy. If we recall what we did, first of all, we put the compass on point B, and then we drew an arc, which is this one. Let's call this arc 1. Right? And because we drew an arc, the arc cut AB at X and BC at Y. That means BX and BY are equal. So let me write it here. BX is equal to BY. Because these two sides or these two lengths, these two line segments are two radiuses of the same arc. That's why they're equal, right? What's the second step that we did? We put the compass on X, and then we drew an arc. And then we move the compass to Y with the same radius. We drew another arc. And these two arcs have an intersection, which is S. What does that mean? That means, let's call this arc 2, and let's call this arc 3. We know that arc 2 and arc 3 have the same radius. Right? Because we chose the same radius for arc 2 and arc 3. What is SX? SX is the radius of arc 2. SX is the radius of arc 2. What is YS? YS is the radius of arc 3. And since we said that arc 2 and arc 3 have the same radius, we can prove that XS and YS are equal, right? XS and YS are equal. So this is our second piece of information. So BX and BY, that's our first piece of information. Now we have two sides of the two triangles. We know that they're equal. We have the last piece, which is BS. BS is a common shared side of the two triangles. And of course, BS is equal to BS, right? Because it's just one line segment. So BS must be same to BS. 3 pieces of information. So let me highlight this, okay? So with this piece of information, this piece of information, and this piece of information, we can conclude that triangle BXS and triangle BYS are congruent based on SSS, right? And since these two triangles are congruent, of course, angle 1 and angle 2 are equal. And since angle 1 and angle 2 are equal, we can conclude that BS is the angle bisector. Okay, so this is how we prove, this is how we construct an angle bisector and how we prove it. So this is the second question.